My name is Scott Lowe. I'm with a company called ActualTech Media. We do content creation and demand generation. I'm going to walk around, I lied. For tech firms like, in fact, Cloudistics and Datrium and Veeam are actually clients of ours, plus a couple dozen other enterprise IT companies. One of the things that I love is hyperconverged infrastructure. You've heard the word thrown around a lot today. How many of you know about hyperconverged infrastructure? How many of you know it and love it? How many of you hate it? Please don't raise your hand. Okay. So one of the, I've been talking about hyperconverged for a long time. So that's before the word was coined. I wasn't calling it hyperconverged then, but I'm a big believer that this is a good way for organizations to be able to simplify and better manage IT. What we're seeing in recent years, though, is that the hyperconverged market is changing pretty dramatically. And we're seeing companies release things that we wouldn't traditionally call hyperconverged. And we're seeing companies trying to take hyperconverged to the next level. And I think all of that is really good for customers. And I'm going to go through sort of my thinking on this to help you understand why I think that what some see as the fracturing of hyperconverged and the sort of misappropriation of the definition is actually a good thing for customers and what it ends up meaning at the end of the day. So, the origins of hyperconverged infrastructure, a lot of people credit Nutanix with hyperconverged. Now, Nutanix has played a huge role in the advent of hyperconverged infrastructure. And I'll provide a definition for those of you who don't know what hyperconverged is shortly. But Nutanix was not the first company to launch a hyperconverged product. Way back in the early 2000s, pre-HPE's acquisition of the company, Left Hand Networks released what was called a VSA, a virtual storage appliance. And that was one of the early hyperconverged products on the market. But other companies, including Pivot 3 and StoreMagic, actually had hyperconverged products on the market prior to Nutanix. Now, Nutanix brought a whole new level of awareness to the market about what hyperconverged is, and they are killing it in the market because of what they've been able to do from a marketing perspective and because they have a great product. So Nutanix brought it into the mainstream, not necessarily invented it, but they perfected it. And back in 2012, when the market was trying to figure out what to call this thing, Steve Chambers and Forrester Research coined the term hyperconverged infrastructure. And I don't like to read my slides to you, but I'm going to for a reason here. So in this, this is directly from Wikipedia, that's why it still says citation needed. They describe a fully software-defined IT infrastructure that virtualizes all the elements of conventional hardware-defined systems. It includes at a minimum virtualized compute or a hypervisor, a virtualized SAN, software-defined storage, and virtualized networking in the software-defined networking. It typically runs on industry-standard commercial off-the-shelf servers. This was the original definition of hyperconverged infrastructure. And there's some key words there. Virtualized compute, virtualized SAN, and virtualized networking that are really important to make sure you understand as part of the foundational definition of hyperconverged. Now, since then, some other, and also this is the other piece that's really important, commercial off-the-shelf servers, basically bare metal, standard, x86, whatever you want type hardware. We don't have to do specialized hardware engineering anymore when we talk about hyperconverged infrastructure, right? So when we look at virtualization in this whole thing, at the core of hyperconvergence, we're virtualizing all the resources. And that's a good thing. So virtualization, the hypervisor, is key to all this. In fact, when we look at how these things are architected, the hypervisor generally plays a pretty big role, either directly or indirectly. So obviously with virtualized computing, we have things like VMware vSphere. That's providing the compute layer, as well as sometimes the storage layer now, but also often the networking piece for virtualized networking because of things like the distributed vSwitch and all that good stuff, the distributed switch. Now, I'm going kind of quick because I only have 25 minutes, so I apologize for that. When we look at what people became accustomed to in the world of hyperconverged infrastructure, there's this generally accepted architecture, and there's a couple variations on this I'll talk about. And there's two different approaches we can take. One is this virtual storage appliance. And what we start with is this piece of hardware. That's a server. It's a beautifully drawn server, by the way, that has CPU, RAM, some storage, and networking, all built in, right? And when we get done, what we end up with is something like this. So pretend this is a server, right? Down here we have a whole bunch of disks in this server. And what we have running on top of this is, say, VMware vSphere running on this server. One of the things that when we look at a hyperconverged solution that is something like a Nutanix or a Simplicity or a Maxta or a whatever else you want to look at that runs what's called a virtual storage appliance, is we have this concept of a controller virtual machine in the form of a virtual storage appliance that is directly responsible for managing all the storage in that node. That VSA works with the hypervisor to provide a centralized storage layer that all the virtual machines then consume their storage resources from. And then if you imagine this scaling out across nodes, that storage layer then also scales out across nodes. There's another variation of this. This is not that important, but I want to make sure you're aware, is that we have same server. It looks exactly identical to the other server, but instead, we're going to run a kernel integrated or operating system integrated storage module that's going to manage the entire storage subsystem directly. So instead of a virtual machine providing the storage to the hypervisor, we're going to have the operating system actually provide it instead. The end result is the same. There are some limitations here. You can't switch hypervisors. When you're running a virtual storage appliance, you can generally run different hypervisors. Here it's tied to the OS. So if you're running, for example, vSAN, you're not going to run vSAN on a non-vSphere architecture. It just won't work. So there's limitations, but there's also some upsides for performance and things like that. But again, that's not that important here, but I wanted to make sure you're aware. When we look at building a hyperconverged infrastructure cluster, we start typically with a minimum of 3 appliances. Not always, but typically. And you'll notice that they're all identical. They all have a CPU, or 2 or more. They all have some RAM. They all have a bunch of disks, either SSDs or hard drives or a combination of both. And they have networking capabilities. And these are all networked together, and they create a single cohesive cluster of infrastructure that you run all your workloads on. Now, if you need more, if you run out of RAM, you just add another node. If you run out of CPU, you just add another node. If you run out of storage, can anybody guess what you do?
Another node.
Who said that? You rock, man. You add another node, right? Super simple to scale. It really is that simple. You buy another node, you throw it in your rack, or gently put it in the rack, and then you add it to your cluster, right? And that's it. Lots of companies do this. And these are some of the traditional players that we see in the space. There's lots of companies out there that are providing this type of service to their customers. There are some challenges, though, that we need to think about. And you'll notice I say true hyperconverged in quotes, and you'll see later why I said that. You scale all the resources linearly. If you run out of storage, you add another node. At the same time, you're adding more RAM and more CPU. You might not need more RAM and more CPU, but you're going to have to add it anyway, because you have to add a node. In order for that virtual storage appliance to run, it's a virtual machine, it has to have RAM and compute in order to operate. So no matter what, with a hyperconverged solution, right now, with some of the traditional players, you are adding additional resources that you may not need, but that's not necessarily a bad thing. It can be highly inefficient. So if you don't need more of one of those resources, why would you add more? If you only need more RAM, why not just buy more RAM? Well, with some hyperconverged solutions, you can do that, but not all. And I'll talk more about that later as well. But it can also be highly efficient. So if you're, especially at a small scale, why would you bother trying to perfectly size every single resource? Especially at small scale, for those of you who have IT organizations are relatively small, you don't often have people that can be experts in sizing workloads. You have to have people that are experts in making sure those workloads operate. So the staff time to deal with trying to size how much RAM or how much exactly storage you need everywhere can actually be more costly than just paying for a little bit of extra CPU, right? CPUs aren't that expensive, and when you start to think about the opportunity cost of what it takes to actually try to granularly manage resources, it can be pretty incredible. So the fact is that there's nothing wrong with this typical approach that these vendors have used up till now. There's nothing wrong with it at all. Would you agree with that, Keith?
I would agree with it.
Keith agrees. You guys can head out. No, just kidding. But are we focusing on the wrong things here? When we talk about hyperconverged, when we look at a lot of industry pundits, some of their friends of mine, not Keith. Keith is a friend, but yeah, I don't associate with Keith. We see a lot of, well, when they talk about the definition of hyperconverged infrastructure, they take a very resource-centric view, right? Input-centric. So it's hyperconverged has to be this perfect appliance that you only add an appliance. You don't add more RAM, you don't add more disk, you add another appliance, and that's it. You don't add more separate storage, you don't add more discrete storage. But how well do those input-centric items really support business objectives? I'm a believer in focusing on the outcomes you get from something rather than the inputs you put into it. And my thinking has changed over the years on this. To quote a former president, I've evolved my thinking on this issue. And so I think the hyperconverged market is actually far broader than, and far more comprehensive than we might give it credit for sometimes. When we think about hyperconvergence, we want simplification. We want to be able to add resources where and when necessary. We can do that absolutely right now. But we can't necessarily, in the strict definition of hyperconvergence, add them granularly. We have to add more storage at the same time we add more RAM and more compute. We also want to simplify management. The entire purpose of hyperconvergence is to keep things simple. So at a minimum, no matter what, we're going to eliminate storage as a separate tier in a hyperconverged world. Full stop. When I say a separate tier, I mean separate management tier. We're still going to have storage, but we're not going to be creating LUNs, we're not going to be creating zones, we're going to be creating volumes and all the stuff, I'll use the right word, that goes along with that process. We want operational efficiency, we want good workload performance, and we want granular scalability, which we get right now. Because if you think about how you've had to expand some of your resources in the past, especially when you need more storage, you're buying entire shelves of disks, for example. You might only need a little bit more space, but you've got to buy a shelf, right? You can find a hyperconverged solution that's easy to scale in an increment that makes sense for your organization. These things are configurable, so you can add small, medium, large. So if you need something that's small, buy a bunch of small ones. And if you want to have a small step size so you can get, so you don't have to buy stuff you need for the next 3 to 5 years, you can buy what you need for today, you can do that. We get that with hyperconverged infrastructure. At the same time, as we're able to scale more granularly, we're able to better contain our costs. And we get closer to a pay-as-you-go model, even in the data center. Now, that's one of the beauties of cloud. CFOs love pay-as-you-go, right? How many were CIOs in the room? Your CFOs like that, right? They don't want to pay for, they probably hate paying for stuff 5 years out. Mine always did. We don't necessarily need to do that anymore. We don't have to be perfect predictors of what we're going to need from a resource standpoint anymore. We can do a good enough job and in a more budget-friendly way, fix it if we need to. And generally, we're looking for a reduced total cost of ownership. And in order to get there with hyperconverged, we have to really rethink how we're looking at the financials of IT. And we have to start thinking about soft costs and opportunity costs as part of our overall TCO. Not all CFOs want to hear that. That's been my experience as well. Sometimes they're saying, we're going to pay for those people anyway, so why do we care? That's a short-sighted view, in my opinion, because those people can be doing something else that's more beneficial and more valuable to the business than creating LUNs, typically. I don't see too many people that have creating LUNs as a business objective in their organizations. Anybody have that as a business objective, to create a bunch of storage volumes? Okay, that's good. James, do you? No. James is my business partner at ActualTech Media, by the way, so say hi, James.
Hi, James.
Hi, James.
So, there's an emerging wave of new options available on the market. And there's also a lot of new terms, because one of the things you'll find with, are any vendors in the room right now? Okay, good. One of the things you'll find with vendors is they don't want to be has-beens or follow-alongs. But that's sometimes the best thing they can possibly do. I was working with a vendor a couple years ago, and they said, we're going to call our solution this. And I said, that is a terrible idea, because it's already been called this for 5 years, and you're going to spend millions to re-educate people. And they still do it. So, and they, by the way, changed back to the other thing after about a year, because it was costing too much money. It's just not a good idea. Let's talk about Datrium. You heard from Datrium earlier. They're doing some really cool stuff. They're calling their solution Open Converged Infrastructure, and they're also starting to talk about Tier 1 Hyperconvergence. Datrium looks very different than that definition we talked about earlier, because they've separated compute and data nodes into separate resources. The key is that they're still managed as a single entity. So if you need more storage, you add more storage. It looks and acts like a hyperconverged infrastructure from an outcomes perspective. You still get the simplified management, you still get one place to manage it, and you still get that granular scalability, but you get even more granular, because now if you need more storage, you don't have to spend money on compute you don't need. Does that make sense? And they're doing some really cool things, as you heard about earlier, that give them some incredible performance advantages over some of the other solutions that are out there, including that no more need to replicate data between nodes. You also heard from Cloudistics. By the way, I didn't know they were all going to be here when I put this together. That just happened this way. We've been working with Cloudistics, actually, as a company for about two and a half years now. And they started out talking about themselves as hyperconverged, and then they moved on to something else. And they're starting to talk about themselves more as composable infrastructure, which is even a different sort of entity. They were using that for a while. But now they're talking about themselves as an on-premises cloud, as you saw. But if you look at what they do, what they provide from a hardware perspective, it looks and acts like a hyperconverged solution. In fact, they have their own, they've customized the KVM, open source KVM hypervisor for their solution, and it's their own hypervisor. And so when you buy it, you're buying an entire data center in a box. And again, separately scaled compute and storage and all that good stuff. They've also done some incredible things with the network that other hyperconverged vendors have not yet done. That's one of the things I really like about the Cloudistics infrastructure. But again, you scale resources independently. For all intents and purposes, this also looks and acts from an outcomes perspective like a hyperconverged infrastructure. Anybody ever heard of NetApp? Right? They're relatively big. They released a hyperconverged solution last year that I don't even want to tell you how many times I've heard from some of my friends, that's not, quote unquote, true hyperconverged. And it's like, okay, first of all, hyperconverged is a made up word. So we can call it anything we want. And now, let's talk about it from an outcomes perspective, not about what went into it. We're getting the same sort of thing. And there are a lot of articles out there that talk about why NetApp is not hyperconverged. It is. Get over it. It works, right? That's what they're calling it, and they're smart to do that. Why try to define a new category when there's a perfectly good one already established? So let's talk about some other examples. Just one. You guys ever heard of a company called Scale Computing? Mm-hmm. Fantastic group. Even if you don't buy from them, go to their headquarters and have a beer with their guys. They're just awesome. They're a great group of people. And they really focus on small and medium-sized businesses. And they are doing some really interesting things. They have a hyperconverged solution that is very affordable for smaller organizations. And they're also now extending that to the cloud, what they call HC3 Cloud Unity. And they're partnered with Google. and that runs their code in the Google Cloud. Now the nice part is that Scale provides their hypervisor, which is KVM. Google happens to run KVM, so it's code easy to transfer workload between the two. And they're also extending to the edge. And if you don't know what edge networking is, think cars. Think anything where it's mobile, where you need to have a place where you can have some local compute, but you don't have a data center. They have their H3 edge that can participate fully in their hyperconverged stack as well. So they're taking hyperconverged and extending it into the cloud and extending it to the edge for things like the Internet of Things type applications. So they still call it all hyperconverged, which they should, because it is. And this all happens to just work as a part of their hyperconverged solution. Okay, maybe there's another example. You guys ever heard of Nutanix? I'm sure you have, if you've been looking at this for any period of time. So Nutanix was, remember, one of those big game changers in the world of hyperconverged. They really normalized this infrastructure for the market. And they now sell storage-only nodes because they recognize that a limitation and the definition was having to scale resources linearly. That's both a blessing and a curse because customers, a lot of customers, still want to be able to target their resources more efficiently. So they have storage-only nodes. They're also beginning to embrace their software-centric nature. There's been news recently that they're going to stop selling hardware in the next 2 years. Have you heard that?
I've heard the rumors.
I don't know if they will or not, but it seems like a big shift. But you know, it's still software-centric. They also have a partnership with Google to extend their platform into the cloud. And they've also got this cloud orchestration platform they call Nutanix Calm that is supposed to encompass the whole data center. So they're doing a lot more here to help organizations be more efficient. So again, you can scale capacity without having to add compute nodes. You can actually get away from vSphere if you want to. They have, again, their own version of KVM called Nutanix AHV. In fact, I believe that even if you're running vSphere, you can run an AHV node as a storage-only node. I believe that's the case, isn't it?
Yes.
So if you, one of the downsides to certain hyperconverged solutions, you have to stay with the same hypervisor and then pay for the hypervisor. You don't necessarily have to do that with Nutanix. So it's more than just a pretty appliance. Okay, I promise this is it. HPE Simplicity, they just throw a whole bunch of stuff in. They went way beyond the original definition of hyperconverged. They do actual full data protection. In fact, 50% of HPE Simplicity's customers ditched their legacy data protection application. So they said, this is good enough. Now that's not necessarily, I'm not sure I agree with that direction because I don't like having anything on one platform, but that's what their experience has been. And they also support a compute-only node as a part of their clusters. So is that hyperconverged? If the idea was we're going to scale all resources linearly, no, it's not. But it's still a hyperconverged platform. Okay, I lied. There's one more. So, a company called Maxta. They're a software-only hyperconverged solution. You buy the software, you buy your own hardware, and you deploy it. Now, the difference with Maxta is you can configure your nodes any way you want. So, if you want more RAM, you take the node down, take the lid off, put more RAM in it. You can put the lid back on if you want, turn it back on, you've got more RAM. Same goes for storage, same goes for compute. So you can do sort of your own thing with Maxta. Now, some people don't like to do that. They want to buy a prepackaged appliance. Well, they have you covered there too. Basically, you work with Maxta, they point you to a hardware partner, you configure with their hardware partner, and you get an appliance on your doorstep that configured from any vendor you want, any way you want, within reasonable limits. So that's still called hyperconverged, even though you can upgrade the individual resources on your own. You don't have to scale out linearly with Maxta, but that's still hyperconverged. So, see, I told you. I lied, but you thought there would be another one, didn't you? Nobody? Nobody? So, the original definition of hyperconverged, and I'm almost done, was really based on inputs, not on the intended outcomes. And I think this has really artificially limited the initial perceptions of the platform and what it's supposed to be able to do. I think what we're seeing in the market today is much better for customers. 5 more minutes? Okay. For lots of reasons. One, there's more choice, and you'll see more about this in a minute. But I think we need to think bigger in this. Rather than thinking about how it scales and how, all that stuff, think about, can it be managed via a single console? Everything. Do we get rid of the storage layer? Can you really avoid having to manage those direct storage constructs? Can you do that? And if you can, that's a good thing. Does it have what you need to meet the needs of your business? Now, there's more that goes into it, of course, but that's where I think things need to go. So what's my point? I want to go to the third point first. I don't particularly like a lot of the analyst firms that are out there. I don't think they do people a great service sometimes. And I hear from people, true hyperconverged. It drives me insane when I hear that. And you don't even want to see my dog. No, I'm just kidding. I don't have a dog. So it doesn't help anybody when they say things like that, because there's so many different ways we can look at this. So when I think about what I see as the emerging hyperconverged market, whatever it's called, whether you call it open convergence, whether you call it tier one hyperconvergence, whatever you want to call it, keep an open mind, right? Understand that you need to be looking at this as outcomes, not necessarily inputs. Ignore the rigid definitions you're going to hear from certain people about what's true hyperconverged and things like that. Who cares what's true hyperconverged? As long as what you buy works for your companies, who cares if it doesn't check one of those definition boxes, right? And really the point here is more choice and more options are good for the customers. And that's why I think that this fracturing of the hyperconverged market is ultimately very, very good for customers. Now I have to do a plug. We actually launched a site called Hyperconvergedorg, 3 years ago? If you want to learn more about hyperconvergence, that has 3 years worth of content on it. And I have to say, in my one data point opinion, it's a fantastic site. So does anybody have questions about what I just talked about? What did I say about lunch?
So are there any new vendors coming out with granular level upgradability across all components of the stack?
Cloud, the two you talked to this morning have that.
Storage and network.
Networking is a harder one. Cloudistics has that. As you add nodes, networking is one you almost have to add no matter what anyway. So I don't see networking as critical to be as granular with. But compute and storage I do. You don't generally run out of networking capacity for the most part. I mean, it happens from time to time. But in that case, add another node. But Cloudistics also takes care of that with their virtualized network. But yes, the Daydream is doing that. Cloudistics is doing that. Nutanix is doing that with storage-only nodes. Simplicity does that with their ability to add the other way. If you just need more compute, you can add just a compute node with no storage. You can't just add a storage node, though, with Simplicity. But there are other ones, James, I'm not thinking of?
Well, really, the
Maxta
is the one that you can upgrade very granularly.
Yeah.
Entirely software just comes with an HDL, it's pretty broad, and you pick whatever you want to do. So
yeah, I think you're going to see a lot more of the big, and I think Nutanix will go that direction eventually if they really do get their software only story straight. So yeah, I think that a lot of them are going that direction, but there's some out there that are leading the way.
What does vSAN fit in like this whole thing?
Yeah.
You know I have to go there.
So VMware vSAN is a hyperconverged solution. If you are already locked into VMware, it's a great option. If you're not, it's fine. It works well. It's come a long way. If this was 2 years ago, I'd tell you just run, don't walk. Today, it's a fantastic solution. It's a great solution. If you're already very vSphere centric and you want to be able to manage resources more granularly, you can do that with vSAN because you can add disks at will, SSD or hard drive varieties depending on the capacitor performance. You just have to pay the vSphere licensing cost that comes with, the vSAN licensing cost, and then click a checkbox on your cluster and it's installed. It's really quite easy to install if you're running vSphere. And again, you can build your own appliances basically with that as well. Thank you for reminding me of that.